Okay, I think I can start. It is the time. So before this, I was reminded by organizers to say one thing, that it is exactly me, that the guy that is standing between you and the beers. And they told me that's how you're gonna like me. Okay. So my name is Jarek Ratajski. I work in a digital asset company. It's very hard to find in Google. It's like, but nevertheless, we exist. And actually, for my daily job is basically writing Haskell actually on production, which it really exists, like something like that, and a little bit of Scala. But for years, I've been writing Java, and then for years, I was working with Kotlin. And actually, this presentation is about my experiences with Kotlin. And I still use Kotlin, however, nowadays, mostly for fun. Okay, so what we'll be talking about is a lot of propaganda today. You should be, you are warned. And then we'll talk about purity and your road to purity. You know, you must be pure. And then how to stay pure, avoid any sins. And then at the end, we'll talk a little bit about making all this nice theory at production. What are the possibilities? Okay, so do you know what FP stands for? What is this? Yeah, no, it's actually, you have to remember, it's functional propaganda. Okay, I'm like a victim of that. But it's known as functional programming as well. But what was the point? Why actually I've fallen into it? Because you know this picture? We don't do deployments on Friday. Who does deployments on Friday? Some of you do. Who doesn't? Oh, okay, there are a few of them. But I hate this picture because it means we are accepting that we are doing shit. Really. And if we are not putting shit on Friday, why we accept that we put it on Thursday, yeah? Maybe we shouldn't deploy at all if we accept this. So the point of it is I want to actually have a good life, good balance, and not worry about putting something on production. And well, I'm quite old developer. I will refer to that. So when I was young, and actually I see young developers, juniors starting, they are basically happy with whatever works, whatever language they choose, and it makes their life easy, like they do something that works, it makes them happy. And I would say in this moment, for instance, when you are starting languages like JavaScript, really, I have to say that, I have to admit that, or Python are great, because you can quickly do something, and those languages are more or less working in a mode, and especially, for instance, PHP is kind of a philosophy. No matter which shitty code you put, I will run it, and let's try. And it's actually, for learning, it's a great experience. And no, I'm not surprised people actually like those languages. But then people go to something else, like, oh, I don't want to repeat myself. And efficiency. So there are two kinds of efficiency that a little bit more experienced developers look for. Like, I want to write this code smarter, a little bit faster, a little bit more elegant, and less lines of code, more power. Or a second is, it must run fast. So there are two kinds of efficiencies, but basically, this is where, like, I don't know, when someone is already knowing how to program, this is where you go. And then comes the problem of, I don't call them all seniors. Because I realized I was never actually senior. I was junior, mid, and then I became old. Just somehow. It happens like that. And all developers actually care a lot about correctness because we already suffered a lot. We've already seen the code. Obviously, it will never break anything. Trust me. And then guess what? Yeah, you will suffer this. And you will feel this shame. And then you will think, how can I avoid that? And there are obviously many ways we have tried. But one of them is, change the style of programming. And actually, I was exposed for functional programming already like more than 20 years ago, but that's a different story. I always thought, back then, initially I thought this is a total toy, and then I realized it's even better toy, because it's like, I write the code, and when it compiles, it just runs. There is no way for it to fail. And that's exactly what functional propaganda says. We'll have less errors. You will have less code to worry about. You will just write less, so more efficient. And you will even write less tests. Because we all try to be safer by writing more tests, but it's actually a lot of work to maintain those tests, and a lot of times we just skip, or we see there are just, sometimes, for instance, we do refactoring and we change the code, and we see we also have to change the tests. And now, what are exactly those tests guarding? If I change the test while changing the code, they are not really protecting me as much anymore, yeah? However, so functional programming promises to solve some of those pains, but one thing about the functional propaganda, we actually, let's say, people that spread this propaganda, we don't say it will never happen. We'll make errors, you will write sometimes a code with sometimes even more ceremony than in Java, and sometimes, obviously, you have to write tests. You cannot avoid that, but basically, a little bit less than without this approach, philosophy. So at the end, now, when I promised you all this, what the hell is this functional programming? So one point maybe, if you asked me what is object-oriented programming, and if you ask yourself, actually, what is object-oriented programming, you would find out this is actually relatively hard to explain. It's just, I know that there are like, when I was studying, we had a simple definition what is object-oriented programming, but then I see the code that exactly follows this rule, and I immediately see, oh, this is not object-oriented programming. So the same happens with functional programming. We have some fancy good definitions, but then sometimes it's not as easy. But nevertheless, there is one definition that I like because it's simple and mostly covers it. So it's just programming with functions. And those functions are basically mathematical functions. Those functions that you learn at school. No, those crazy ones that you learn in C or, I don't know, Pascal. The real mathematical functions which are deterministic, total, and pure, and I'm going to explain that. By the way, obviously, this is stolen from someone actually that I follow and I recommend. But okay. So what is deterministic is the easiest to explain. The function that depends only on arguments. And oh, sorry, it's from the DevOps Ukraine. I used the wrong slide, but okay, I will follow this. That was last week. I forgot to copy the correct slide. Okay, happens. So should be, what should be? Vox Days Milano. But okay, always get the same arguments for the same results. And for instance, if we have this function hello, which doesn't have argument, from functional point of view, it means it should return always the same result. It's a constant. Because if if there is no argument, we can only be a constant. The second one is easier, like factorial, we have n, and we always return the same result for the same n, even though we have some recursion here. And okay, here is a counterexample. We have some function that not only uses random, but also depends on a global variable. In that particular case, obviously, it's not deterministic. The variable changes, and the function gives something else as a result. Okay, so totality. This is, by the way, very simple if you ever learned mathematics. If you've been to primary school or someplace like that, you learn that the function yields one and exactly one result for all the elements in the domain, and okay, result in the codomain. So basically, that's it. Like, function must always give you a result that you can assign to something. And for instance, some examples here are obvious, but let's talk about this parsing. If I have this parsing, by the way, I'm already exposing you to Kotlin, forgive me. But it's like very easy to learn, to understand language, so parsing string and then to int. And this function throws exception. Is it total? No, because we cannot say x equals parseInt1 something and expect that we always will have a result in x. No. So the second version is this. Is this function total? So we catch exception and return -1. What do you think? Is it total? Is it stupid? Yes, it's very stupid. It's total, but it's stupid. And the third function is actually how one would do that in functional programming. You would return a special structure which you can assign to variable, and actually there is nothing like throwing exceptions here. It's called a try. I'm not going to dig into that, but basically for all the results, for all the strings, you will get something. Maybe this will be a description. Sorry, I cannot parse it for you, but it's still a value that you can pass somewhere. And the purity is actually the hardest to explain, and I don't have and actually this is where we have the most problems, how to actually define the purity. But basically functions should leave no traces. And it is also called referential transparency, but you shouldn't be able to distinguish if you have a function, if it was really called, like here, or someone just assigned a value. So basically, if you are here in this place of the code, you shouldn't be able to find out if before someone called this function or actually gave you X instantly because calculated it offsite. Yeah? So no matter what you put in code A and B here. Okay, so some examples maybe for this, because it's complex. So we have function add, which is obviously really horrible if you have in code multiplication and call it add. That's how you can do. But it is actually a great mathematical function. It is pure, total, and deterministic, and stupid. It can happen. But nevertheless, then we have a add2 function, which makes some threads leave. And now, if you go back here, you can detect that it was called, because you put here like checking of time, you calculate how much time you spend actually between those lines, and you can detect, oh, it was obviously called in the middle. So we know this second function is actually impure. What about the third one? It locks something. Is it pure or impure? So by definition, it is impure because it locked something. And now there is something like, if this is the diagnostic log, that application actually never shows to user. It's only for you. It's internal thing of the application. It's only for the developers. And now you never read an application from this file. You just use something else. We can call it practically pure. Like we actually do this, how to say that, shortcuts. And we can consider it's theoretically impure. We can call it practically pure. Pure enough. Okay, so sometimes we cheat a little bit in functional world. However, and having said all of that, what is actual killer feature of functional programming? There is exactly one, composability, and why? Because if your all functions are like these mathematical functions, you can compose them, and let's say as long as it compiles, you shouldn't expect anything crazy happening. Like you know this feeling when you just change something in those few lines here in one method, and something completely different in different place of your system just falls apart, just explodes. And then you find out, oh, there was this chain of things that happened and affected. It doesn't happen here because of this all purity, and that's it. Nothing less, nothing more. Okay. We started with the first part of propaganda, now to the second, Kotlin. So actually, kind of, maybe I shouldn't say love totally Kotlin, but I do like Kotlin. And what is a Kotlin killer feature? Who knows? So it's easy if I show you the keyboard of typical Java developer. Have you spotted something? Right here. Yeah, completely abused key, semicolon. So Kotlin doesn't require you to use semicolons. Oh, this is great, awesome. And that's how you start love with Kotlin. But there are also some other interesting features. That was a critical one, but now some interesting. So data class, who knows what a data class is? Okay, who knows what a record in Java is? So data class is basically something better than record, and I will show you. So whenever you want to do a class which basically represents data, use in Kotlin something called data class. And it looks like this. So if we try to rewrite it in an old style Java, that would be with getters, and obviously I don't have setters because I never change things. I never change things. I will refer to that. So I don't have setters. I have final fields and now getters. And that would be more or less this record, this data class. But then I remember there was like a default parameter for a person. Like by default, we assume that someone is drinking. So we have additional constructor right here. Okay, I don't have a place for full code. And that's it. No, then we remember that there is equals in hash code. And by the way, Java records also provide it. So we have additional methods. And that's it. To string, almost forget about it. Now we go back to Kotlin and play with this class. So we create P person, that's a name, Irek, who is 27 years old and is drinking. And then we realize, okay, we don't start names with a lower case, so we have to fix that. But you know, we are in a FP world. We cannot change something that was created. We have to copy and change and we do this with a method copy, which by the way, I've never written. I didn't have to. Compiler generated it for me. And now I have two instances, two different objects. One, let's say wrong, initial one with a lowercase and the second with an uppercase. How cool. This is exactly what I want. And I can do even more. I can change age. I can change two parameters at once. All that using this copy. And now I can think, what effort would that be to create this copy in Java? And yes, that's a little bit to write. All the combinations, etc. So if I make a little bit smaller font, I can put some of those methods. Still, doesn't fit the screen. So almost there. Oh. With that font, it really fits the screen, so you know this data class. And it's 30 semicolons in Java, also on that picture. You might not see them, but they are there. And if we use this font for Kotlin, that would be this exactly. And okay, not convinced. So what if you had 7? Because we are, obviously, if you are writing real enterprise programs, obviously you have classes with 20 or more fields. Yeah, and then imagine writing copy for all those combinations. That would be a lot of fun. Okay, so the point is, records are great in Java, great that we have them, but they still don't have this nice copy. They will probably, because there is right now exactly a discussion about how to bring something like that. Well, after 5 years, we'll get it. Okay. So, and that's one point. So data class is something I initially, when I heard about it, I totally underestimated how big this thing is, because what it means is we can simply have immutable records that are easy to use, that are fun to use, that I don't have to write all these helper functions with name changed or whatever. And it changes a lot, because if I don't have to, now I don't struggle with writing immutable classes, because those are easy to write, easy to use. And immutability, as I've shown, is a critical thing for having deterministic functions, because if you have something like depending on a field, depending on something, that obviously means your methods won't be deterministic. So you need immutability as a first thing for doing functional programming, and data classes help you with that. And they are easy to use. And basically, immutability as a whole, by the way, this is the first time I saw this when I have seen that when I was, I don't know, 13 years old, first time, x equals x plus 1. And immediately my brain started to boil. Like, what is that? It's obviously wrong. Then I fallen into this trouble. Oh, that's an assignment, but what is assignment actually? So it's actually immutability is, there are some persons that I don't know that really cannot understand this. X equals, you all accepted this. But there are people in this world that start to program and they say, oh, I don't go from this point anymore farther because it's already crazy. And then they learn about, actually they can have a Haskell where that craziness doesn't appear. And they are actually now then learning Haskell, for instance. But we are in Kotlin where actually you can write x equals x plus 1, but you don't have to at all. So one is we don't change variables. We actually have only constants. The second, we have immutable records objects. I've shown you with data classes. And the third thing that is needed to have this immutability, so deterministic functions, is immutable data structures. I'm talking about lists, trees, hash maps, and I'm using Wave for this. Who knows this Wave project? Oh, some people know. Previously it was called Java slang, and actually this is, we can call it modern Guava. So Guava, obviously, probably most of you heard about Guava. But obviously Guava is a bigger project, but Wave is just immutable data structures that are fun and easy to use. And I will show you, and I've started to use Wave even in Java back then, but those things are still, this whole library is quite useful in Kotlin as well. So that's example how you deal with a list. For instance, we have list of 1, 2, 3. 3 elements on the list. That's list 1. And then we prepend 0 to this list. And then we have a second list. And actually, those two are independent. We don't really mutate the list. And one might have asked, what? If this was 1,000,000 elements, how much would it cost? Okay, the same amount of CPU as here. More or less some, it's actually exactly. And how much elements would we have in memory if I had 1,000,000 elements and I prepend 1? And I have 2 lists. One is 1,000,000 elements long, second is 1,000,001. Actually, I would have in memory only 1,000,001 elements, and not an element more. And this is, but how this magic works is additional story. There are talks about it. And there is actually no magic. This is easy to understand. And it's not only for lists, it's for arrays, actually. So vectors, they are called hash maps. You can all have this. So actually, immutable data structures that are efficient in actually when you change something. It's not that I copy everything. Absolutely not. Not that how we do that. We are way smarter. And there are some people that don't like this approach with Wave because they say, we have immutable lists in Kotlin. The problem, immutable lists in Kotlin are actually wrappers for Java util lists, which are not efficient if you try to do immutability. So exactly if you use default Kotlin lists, you will have this problem. You add something before, and now you pay the cost of duplication and actually even extending arrays, all that stuff. So, but on the other hand, in a real typical world programming, the lists that you face most often are actually of a length 0, and then of 1. And you rarely have lists that are longer than 20 elements in practice, which means that if you do typical enterprise software, you actually still can use that. And even though I don't like Kotlin internal lists, they are still good enough in efficiency in practice. So, and yeah, I will skip cheating on that. And then there is your Java util. And basically, even back then, many years ago, when I was a Java developer, I knew one thing: you just don't use Java util. That might come as a shock, but no, almost everything in this package directly is broken. Even optional is broken. That's another story. But basically, because those lists are absolutely horrible when you do typical business software. You have a list, Java util, array, whatever linked list, typically use array list. You pass it to the method so that your colleague can calculate average, but he is smart and removes the highest and lowest element. And yeah, he calculates average, and now your list has changed. How fun is that? Especially when you track errors. And it actually happens. And I tell you, You don't even notice that, how many times you have this bug that you passed list somewhere and it was modified there, because you accept it as something that's obvious. You obviously have these errors. But when you switch to Vector, even in Java, you don't have to go Kotlin, you realize, you just see that this disappears, and again, you don't see that. But then if you go to Java array list, you see, oh my God, it's all full of traps. You would never want to go back to this. That was experience of me and my colleagues in the past. And basically, lists are not equal. I do really love this Vector. And by the way, there are alternative projects, but I don't really use them. I cannot recommend. But surely there are other great projects. Then it's Kotlin immutable list, so kind of native. It's still better than Java util lists and everything, which is just full of traps. You might do it in a small piece of code that you review multiple times with many people because you fight for efficiency. But don't do it in a typical business project everywhere. Yeah, okay. Next thing about functional programming is actually, this is a little bit out of the initial scope because original definition of functional programming doesn't say anything about types. Types are not required to do functional programming. Actually, there are people happily writing Clojure, other Lisps that have fun without static types. Maybe that. But I am in this group of people that love types, especially if I don't have to pay for them that much. And what I'm referring to is var and val. And Kotlin, as Java, has a var keyword, but has one better, val, which is basically final var. What else? And obviously, how var works, I don't have to explain to Java developers. But there is one more thing about Kotlin, because var in Java is relatively limited. We can only use that inside methods. But what about fields? Nope. And in Kotlin, actually, there is just exactly for that. Even more, there is something like a mix. In Kotlin, you have the first line, you see the constructor in Kotlin. And val there means this is argument of constructor, which automatically becomes a field. So you just are freed from this ceremony of assigning this x equals x, yeah, like in typical constructor. But okay, obviously records also don't have this problem. But the point is, what I really like about this language, and that's not only this, is actually it has one syntactic rule. Val, name of variable, okay, constant actually, and optional type after semicolon. You don't have to put it. Mostly it will be automatically calculated by compiler, but is there, and for all cases where you want to use some kind of variable field, whatever. In Java, it's actually more complex. So funny thing is that language that is a little bit more powerful, and I will show you that, is actually simpler. It is. So one syntax rule that you can use everywhere. Okay, I will have to go really quickly right now. And this is something that really bothers me a lot, because from time to time on the Twitter, I see that people argue, oh, var in Java context is actually unsafe. There is no type. This is like dynamic language. It's totally wrong thinking. Exactly, type inference and var means type safety. Wow, yeah? But if you probably have doubts, some of you. So I will refer to something like one of the first companies I worked for. And that was 20 years ago, more than 20 years ago. And they had this password policy because they wanted to be very, very secure, you know. 12 characters, all these special characters must be changed weekly. Actually, that was bi-weekly, but nevertheless, and must be not like recent 20 password. You can imagine, this is very secure, yes? Yeah, that was very secure because more or less I realized quickly that everyone has his password kind of pattern with a number of week and first name and written under the keyboard just in case. So it was really great. And we learned since that. That's not how we deal with. Actually, two strict rules are causing the problems because they are inhuman. Yeah, so we actually want to have a little bit looking like less strict, relaxed rules, but they in practice work better. Yeah, but okay. And I'm referring to this. This is the hash map definition. Okay, this is in Kotlin, but it will look the same in Java. Would you like to write it many times in your code, this hash map of something, something, you probably wouldn't. You would probably think, oh, this makes my life miserable. And you would think about shortcuts. And this kind of a shortcut is hash map from string to string, because after all, you can almost always represent everything as a string. So, and I tell you, this is the lesson outcome. Even you forget all the FP. Every time you see in the code hash map from string to string, this is a place that begs, give me a proper types. Don't cheat with these strings, because probably key is glued of some two components and the value is actually something that can be a proper type, but you cheated because you have to pay the cost of repeating this. So instead of proper types, you used string because, yeah, you could have used object. That would be even smarter. But okay, so in Kotlin we don't have to write these types. The compiler is mostly smart enough, but even more, we have type alias. In case we want to express ourselves for documentation, we can have type alias, which is basically like just replace this, and this is a cool, other cool structure. So this is cool. We have static types, but we don't pay that much for them. Actually, they are easy, and then we have to less to write than in Java. And I would say, in practice, we have to less to write than in Python. Wow, really. But okay, this is a different story. But the next step after you resolve the immutability and you have static types with var keyword comes expression. And this is a huge step. What are expressions? Basically, we have two times the function written in different styles. First is like classical C, C++, Java. Actually, it starts from BCPL or even Algol. Okay, BCPL, let's say. Return A plus B, instruction, that's it. And second, we used mathematical way of writing this. A plus B equals A plus B. And that's exactly the expression that the whole body of this can be inserted as value x equals this. This is expression. And this is a huge power. Why? Because it actually forbids you from using all this heresy and blasphemy. Like, return is just a brother of goto, because you can skip from if something and return. And with expressions, you can't do that. And that's actually cool, because how many times you had this if, return something, and then some code, and then you realize actually the bug was because someone forgot to do some cleanups, etc. Because, yeah, you return as all the gotos works fine when you first write it, but it doesn't survive refactorings. Okay, if you have return at the end of the function, it's not one return for a function, which is basically one of the rules how to write safe code, it's okay. But if you have multiple returns, sooner or later you will realize that it actually leads you to a problem. And expression solves that, because automatically this is like, there will be only one return, and just that's here. There is no way to write another one. Basically, instructions are not funny. Instructions are not funny because you can write code with instructions, but it doesn't survive well refactorings. Okay, and now we have to skip a little bit because I was very slow and I don't want to interrupt your, go into this beer phase, keeping you too long. We have this domain, order created, paid, and delivered, so exactly something that now comes to Java. And I don't have time to dig into that why it's cool, but it's cool. And we have a database, and the best database you can have is a list. I have created order, paid order, delivered. And now comes the business and says, we know how much we have on account, but tell me how much should we have from our database? Because all the orders that were paid or delivered, this money we should have on account. And created, no, because someone just created order for pizza, I don't know, and this money is not yet paid. And there is one way of writing that. With instructions, you see this impure sum function in the middle. We just do a for loop, we have variable, it's so awful. But it works, and it gives correct result. What's the problem, yeah? It works. But then, In other universe, there is a functional freak that knows everything must be expression. And you write this sum equals. And now you can't do a for loop. For loop are just no-go in functional programming. You have to use something like fold. So basically fold is if you used streams, there is something like reduce which resembles fold, but it's really a little bit crappy, but still close. But fold is basically a recipe how we calculate value from the list. And once you learn the power of fold, you will even start to use that in Java. I really tell you that because it's so much safer to use. So we start with initial 0 because the sum initially is 0, and then we provide the recipes. If you find paid, then you have to add the sum. If you find only created, then you just leave accumulator as it was. And that's no surprise, we calculated correctly, that's okay, yeah? So what was all this about, yeah, if nothing really changes? So the business people, you know them, are trolls. They tell you something and they then change the rules. And of course, if we are agile, we never change anything in our projects, we stick to the Scrum planning, but if we are not, then we actually adapt what they say. So they tell us that we now have new types of orders, which are canceled because someone, for instance, paid, and we decided that we can't deliver this pizza because we don't like the guy, so we cancel, we give him back money. Or archived because it was paid delivered, but people from the business don't want to see that on the screen. So maybe because it was already yesterday. So, and for canceled, we don't have money on account. For archive, we have. So we edit, and we are happy. But then, in most of the cases, everyone would forget about this function, which calculates the sum. Because how would you not forget? You would have to go through all the code. Would you really, whenever you add something, you'd go through all the code to check what's the potential influence on this code? I bet, no, maybe you remembered, but you know, this was a code that some Joe wrote 2 years ago and left the company. You don't even remember this code exists. But next day, people from business are in panic because the numbers on the screen doesn't really correspond to what they see on account. And okay, this is something easy to fix, but there are bugs like that which are not that easy. But what happened in the world when someone did it as an expression? Actually, in this world, this thing didn't compile. Why? Because compiler, not having the idea how to actually do this value for canceled and archived, basically couldn't generate the code because it has expression. Expression must be calculated for all these branches. It's actually here, compiler was kind of forced to remind you, oh, please provide me the all other definitions, so this bug never goes to production. So expressions are really, really safe, and compiler, actually this is the old developer explanation what a compiler is. It's your best friend. It will not tell you, oh, everything is fine, you will just do. No, it will tell you the bad things about your code, but it will prevent you from going with this bad code on a production. Okay, and by the way, in Kotlin, everything like if, even try is an expression. So you can really fully do all the functions, and I do it as expressions. So, okay, I will skip part when we do more safety because we don't have that time, but side effects. So contrary to popular opinion, because now comes the next step. We have expression, immutability, types, and now comes the side effects. And contrary to popular opinions, functional programming is all about side effects. The difference to imperative style, or you might know it as object-oriented, is we don't just accept that side effects happen between the lines, somewhere there. We explicitly see them, we manage them. We want that the compiler, that the developer is aware of them and manages them. Okay, effects are about this purity. And if you had, for instance, paid order, you might have a deliver function which gives you back delivered order, but does something as well. So here we simulate impurity by printing. And this is impure code. And if we went with that code, maybe we have the function do everything at once, like a service, By some, we create, we pay, and we deliver. Everything is fine here. But then the business comes and says that all the orders above 20 should be delivered fast. And someone, again, maybe this is in a longer code base, makes this stupid mistake that adds the if, but forgets to make the else. And then you have delivery twice. And you lose money because you deliver twice, I don't know, pizzas, but it is only paid once. This kind of errors happen. If you don't manage your side effects because they are just somewhere between the lines. You don't see here that something is printed on the screen. Yeah? But how to do it purely? So here is a little trick. And actually the trick we use and it solves all the problems. So this function, is it pure or not? It prints to the screen. This is totally impure function. But now, what about this function? And I translated it to Java. It actually returns you lambda. Is it pure or impure? This is the trick. This is a pure function. The result of this function is a lambda, which is impure. But the function itself, say it, is totally pure. So just pack all your nasty stuff inside lambda and you are great. You are doing great. That's exactly more or less what we are doing in functional programming. So, because by the way, by definition, now you have this function, say it later, and there is no way to find out if this x value was really a call to function or someone just assigned this lambda as the x. The x itself, the result is impure. We can say that impure value, wow, how cool. But the function is pure. It says, I am fine, there is nothing wrong. So back to the problem, we can actually rewrite this code with a structure that I like called pancake, naleśnik in Polish. And this is it, what it has this action, it has this lambda called action. So basically it wraps the lambda. Why is that? To make life easier, and I won't explain, I don't have time, but it has two functions you should know from optional, map and flat map. So change something that you have wrapped, and in case you have a recipe how to change the type, for instance, this is a action that gives back int, and I want to have, and now I have recipe how to, from this int again make action that gives you action that results in a string. I can use a flat map and have one, let's say, wrapper about it. And then there you have this function unsafe run, and it is the same as in optional get. Who uses optional get? Oh, that's so wrong. You never wanna use optional get. It's exactly the function that should be forbidden. Actually, in Haskell, we don't have a get, more or less, let's say. There is like, if you use something like get in Haskell, that would be like blasphemy. And actually, you don't have to use mostly. In Java, maybe sometimes, but mostly not. And it's exactly the same with this naleśnik, which you have this unsafe function, which you actually only use in main method, or when you have a controller just at the end. We say at the end of the world, at the end of the execution, but never in the middle. Avoid that. And then what we do, we write all our code that all the actions happened inside this wrapper naleśnik. So I just wrap impurity inside, as before with this lambda. But now I have structure that lets me flat map, etc. And what now happens? Even though I have the same bug, I still have the same bug in code. Actually, because this delivered from the third val was never given as a result of this, it will never be run. And wow, how cool, I just avoided twice delivery. So this is just example, I don't have time to go into the details, but basically this pancake structure makes your life easier, not how to first you see side effects, because it's now a type. This is a proper type, side effect that results with string or int. It's visible, you manage it. And naleśnik is just something we eat in Poland, which is much better than burrito. And burrito is known for something called monad, and exactly naleśnik is something called IO monad. Who actually ever used something like React or Java RX or something like that? So if you use that, this mono or single or something is more or less the same as IO monad. So it's nothing really that unknown in a Java world. And okay, in Kotlin we have some other ways to write it in a more smart way. I don't have time for that, but okay, finishing. How it's on the production. So the problem on production with Kotlin, even though, for instance, I am writing Scala and all that, even with databases, with all these side effects I can do in Scala purely like this, there is nothing that I know that is ready for Kotlin. So in a typical project in Kotlin, I was writing my side effect wrapper, for instance, for transactions, database transaction on my own. How cool. This is very naive implementation, practically way longer, but it worked. And that was cool. And there is a experimental project that I created called Ni that basically brings the generic side effects. You can check how it works, which is kind of emulate Spring with a functional programming. So instead of using this transaction, you can have transactional secure, these are annotations, but what if I hate annotations with passion. What if I change them into this impure and I say it's security, retrievable cache, and takes, and by the way, now you know even in which order they appear, because if you write annotations, actually, you might wonder one moment, is the security check before or after cache, which is important. Here it's explicitly written. And I say this is an experimental project, but you can look at it, the code is there. One more because I'm finishing. The problem is how we check if the code is pure. So actually I created a tool called Kotlin, which basically is a plugin for something like a check style for Kotlin, which is the detect is the tool, and it has plugins that actually allows you to check for all the impurities. You cannot use variables, voids, for loops, whatever. And if you use this plugin, and I use it in some projects, or on some projects for some modules, critical modules, then your code is actually more pure than typical Scala code. Wow, actually Kotlin can be full FP, and actually this proves, and I have such projects. So basically, we are limiting our power. We are not using loops, we are not using variables in order to provide safe code that won't surprise us with errors, and specifically that will survive refactorings. That 2 years later, someone will mess with this code. And if he tries to do something nasty first, compiler will react, second maybe this tool, but this is FP, protecting, making the code stable. You make less error and you leave place for less errors for future generations that use your code. Yeah, if you just follow these rules, which by the way may sound crazy for those of you that haven't tried, but I can guarantee we have projects which are written purely in Haskell that do things with database. Wow, that work on production. And there are few, let's say, pure FP. Obviously, we cheat some places, but not as much as you expect. Actually, we cheat maybe in libraries, but the code, the business code is clean and pure by definition. Okay, there is a link to this, to the code samples in Kotlin, and thank you, that's it. It was a pleasure.